So, hi everyone, and welcome to this third video in the series, which is about the chi-squared test in Python. So, the chi-squared test, we typically use it when we're dealing with more than just two outcomes. So, notice from the last video when we did the proportion of males and females over work, there were just two proportions, males and females. But what if we wanted to sort of do a test wherein it was more than just two possible outcomes? For example, we have in our data set here the variable region, right? So the region variable okay, has more than two outcomes. It could be northeast, northwest, west, and the south. So we need a test that can be able to distinguish okay, between more than just two possible outcomes. Okay, so what we're gonna do is we're gonna run sort of the chi-square test. Okay, so how to do that in Python. So the first thing we're gonna do for simplicity is we're gonna recode the region variable to be 1 if northwest, okay, 2 if midwest, 2 to be uh sorry, it's northwest if 1, midwest if 2, south if 3, okay, and let's see, and west if 4. Okay, I think that that's gonna be the case. Just to make sure, if we go to the code book here, you should see there, south, northeast, midwest, south, and west, right? So that's what we have. Okay, and then we have here there, okay, done it correct. Okay, so as we did in the two sample proportion test, one good thing to do is we first make a frequency table, right? Like frequency table. And making the frequency table, basically, okay, so let's make a frequency table between region and our variable of interest, which is still worked with row and column totals. Okay, okay. So we have here the variable overworked, okay, and we see that there are 4,075 people who classify as overworked in the Midwest, 3,300 in the Northwest, 4,700 in the South, 3,926 in the West, okay? Now, since this is still a proportion sort of test, okay, we're gonna generate a frequency table of the proportions, okay, of the proportions. Okay, so let's try this. Okay, so we should be able to so get along with that. Okay, okay, and we're give me a second here. So let me be more granular. Generate a frequency table of proportions between region and overworked. Right? So that should give me basically the proportions of that particular table above. And that's exactly what I wanted. So we see here, okay, that on average, 30%, 33% are overworked. Okay, in the Midwest, 34% in the Northwest, 29% in the South, and 30%, okay, in the West. Now, what we want to sort of test is there a statistically significant difference in the proportion of people overworked across different regions? That is this number statistically different from this number? Is this number statistically different from this number, and so on? Now, in the past example, it was sort of very clear between males and females. Here, it's not so clear because we're reaching sort of a number hovering around 30%, right? So let's see if the chi-squared test can give us some sort of, can shed some light around this particular difference. Okay, so we can run a chi-squared test, okay, on the proportion differences across regions. Okay, so let's try to do that. Oops, my bad. Let's see this. Okay, So what we need to do is import from SciPy a package called the chi-squared contingency test, right? Which is the chi-squared test. Okay, that test will output a couple of things, a chi-squared statistic, the p-value of that test, the degrees of freedom expected for that, as well as the expected count, right? So, and that will take in basically the arguments inside of this frequency table that we see here. So inside of this, we'll take these arguments and we can run this very quickly. And we see indeed a very, very low p-value. So in this case, we find that there is a statistically significant difference, okay, across these regions. So we conclude that there's sufficient evidence to say that the proportion of people overworked in each region does vary across regions. So that's it for the chi-squared test. Thank you for your attention, and I'll see you in the next video. Thank you so much.